Hello guys, welcome back to Quadratic Functions. In here I'll clarify some questions connected with X and Y intercept. So what are X and Y intercepts? Simply when you have the parabola, so visually you see the graph of the parabola, you see some points where your parabola meets x-axis and y-axis. So that's simply what X and Y intercept means. So that's typical for any graph. For example, for a straight line, it should have some X and Y intercept. It might be the origin, might be any other points with different coordinates, different from the origin. So that's why generally we can consider x-intercept as just the value of x where your graph, your parabola, or any graph meets the x-axis. So x-intercept can be found easily. Let's consider indeed just any graph. I put a random parabola here. Oops, not so good. I'll do it one more time. So let's say we have parabola and we would like to see where the function crosses x-axis. Okay, so that's two x1 and x2 values. So actually, if parabola goes in a different way, for example in this way, it just simply touch in one single point. So in this case, vertex and x coordinates for the vertex become x-intercept. So because x-intercept is the x coordinate, it can be found easily by plugging y equals 0. You ask why? Because have a look, no matter which point you take, this one or even that one, so for those points, they completely lie on x-axis. So that's why when you consider x-axis, so any point should have y equals 0. So for any point here, y is 0, and for both x1, x2, so you can state that y is 0. So that's why if you have quadratic equation for your parabola, you just simply plug y equals 0, and right hand side of the function made in standard form is simply 0. So that's why if you have a parabola in general form, let's say y from x equals x squared plus bx and plus c, you just simply need to say, okay, now y is 0, and you need to solve not simple, but like complete quadratic equation that's written in standard form. So x squared plus bx plus c equals 0. So I hope you remember how to solve quadratic equations. So just, I remind you, either you need to find discriminant, so you just go through discriminant, specific expression that contains b squared minus 4ac. This is on the way to quadratic formula, and then you just find x1 and 2 as minus b plus minus square root of this expression, which is discriminant, and over 2a. So over 2a. So you can do using this way, or you can factorize. So the first is through discriminant, the second is through factorizing. So factorizing. Okay, so let's see how it works. Let's say we erase our parabolas, and instead we would like to find x-intercept for a specific function. And let's set up this function. Okay, perfectly. So let's consider one simple example where we're supposed to find x-intercept. Let's say we have y equals x squared, let's say minus 3x and plus 2. All right, I'll show you in two ways, through factorize, through discriminant, but the main goal here is to complete an equation and say that when we have x-intercept, we need to equate your function or y value to 0. So when x-intercept, when we're looking for x-intercepts, all right? So that's why we have quadratic equation, and let's say I factorize using x plus a and then x plus b equals 0. So that's my sample, and now I know that the product will give you 2, while the sum A and B should give you -3. That how it works. Just for those students who don't know or don't understand why is it so, just go back and see the topic about quadratic equations, where I apply different methods through factorizing, through discriminant. Just try to watch my video one more time. That's quadratic equations. That's the whole list. Alright, so here we're just trying to guess. So the product should give us +2, while the sum is -3. So my option is -1 and B is -2. So because when we sum up, we'll get -3, and we'll multiply, we'll just cancel out 2 minuses, so we'll get +2. So that's why instead of A and B, we'll just simply have x minus 1 times x minus 2, and the resultant will be 0. Okay, so here is x1 is 1 and x2 is 2. Okay, so we found out x intercepts, so they're actually x intercepts. So hence we can plot them here. So 1 and 2. All right, so we've got the point nearby, but actually I need to clean it up. Okay, so perfect. I'll try to clean it up also, that one. Okay, perfect, it works. Yeah, so I just put x equals 1 and x equals 2. That's here. And let's try to provide with the sketch. So my equation is that one, and highly recommended to have x vertex. So what guys do you think about if we have x intercept 1 and 2? What do you think about x vertex? Yeah, you're right. So we can find it as the average of 2 coordinates for intercept. So if we do have 2 coordinates, in case of 1 or in case of no intercept, like 1 is if the parabola touched your x-axis, so no, it means that parabola completely above x-axis or completely below. So in this case, we're not able to define x vertex by applying this arithmetic mean. That's simply arithmetic mean. We can only apply when we have x1 and x2 intercept. So actually, yeah, for touching case, when we have a touching point, so this touching point actually will be the x-intercept, and x vertex coordinates. Okay, so but if there is no touching, so obviously we need to calculate using standard approach for how to calculate vertex coordinate x vertex. Okay, so let's calculate 1 plus 2 over 2, we'll get 3 over 2. And let's check it using the formula x vertex is minus b over 2a. So in our case, it will be +3 and over 2. So which is actually the same as we've calculated. That's it. Again, one shortcut that you can use. So if you understand that actually just why we can use that, because we know that x vertex, from x vertex, the distance to x1 and to x2 the same. So that's the distance. And by the way, we can also calculate that. So we have coordinates 1 and 2. How to calculate distance to the vertex? Simply we need to, what we're going to do, we just need to subtract 2 minus 1 in order to get the whole distance, right? So that's the whole distance, which is simply x2, the highest minus the lowest, or just take absolute values, modulus, right? That simply means 2 minus 1, and that's why, so the total distance, so actually this is double distance, yeah? We're talking about the distance between x1 and x2, we mark like that. So we're taking x2 minus x1 absolutely, and we've got 1 finally. So that's why for each distance to every single x-intercept, we have a half. So we get 0.5 for each one. All right, that's again like a very interesting observation that you might bear in mind and keep it in memory. All right, and use. So okay, we've got 3/2 as the vertex, and this is exactly the line of symmetry, right? So we use that as the line of symmetry, and just right now I'm going to put that. So I'm going to use that as the line of symmetry. It goes down, yeah. So something like this. And what about our y vertex? We found out it's 3/2. So can we find the y vertex? Yeah, of course. We just simply need to plug to find y vertex y from 3/2 and just calculate how much we get. We just plug in our original expression. So this is x squared minus 3x plus 2, and we need to plug it there. So we've got our equation one more time, x squared minus 3x plus 2. Yeah, let's compare. Yeah, that's the same. Okay, so here we just need to plug x vertex 3/2 everywhere, here and here. And let's calculate. So y vertex is simply 3/2 squared minus 3 times 3/2. Okay, and plus 2 finally. So what we're going to get, 3/2 is 9/4, negative 9/2 and plus 2. So here we get 2 times, and instead of 2 in the bottom we can get 4, right? And that's why we'll get negative 9/4. So 2 minus 9/4, which is negative 1/4. That's the y vertex. All right, and in this case we're gonna do that. Yeah, just we put it like very 1/4 is actually not here, just is gonna be closer to x, but because of my limitation, so I'll try to drop. Okay, let me check how it works. Plus 2. Okay, should go through 2. I'll explain in the next part. Okay, so that's your parabola. So y equals x squared minus 3x plus 2. And here how we can set up both intercepts, which are 1 and 2. Okay, and we also can check the distance of 0.5. So obviously it's here. So here and here, as you can see, and the total distance is 1, right, between two intercepts. Okay, so we just mark that this is x2 and this is x1. So two intercepts, right, x2 and x1. All right, and we've got a vertex. So if you like, we can put a vertex with coordinates 3/2 and negative 1/4. All right, so that's the vertex, and that how it looks like. So that's the complete like manual how to find x coordinates, how to find the vertex, how to find the distance between like the vertex coordinate and any x-intercept, and how to plot the graph having this x-intercept, having the vertex. Okay, of course, to be more precisely, you need to add like more proper points. So in this case, you need to set up the data, the table for values x and y, but this is for precision. However, if like the critical points actually to x-intercept, the vertex, and one more significant point, what I'm going to tell you right now. So y decided is 2. All right, let's define y-intercept in this case. This point is called y-intercept. This is y-intercept. And actually, I decided it's 2. Yeah, it's very simple. I just have a look at the free coefficient, and this is actually y-intercept. So y-intercept, what is by definition? So y-intercept is where your graph, in this case it's parabola, it crosses y axis. Okay, that's another like crossing point or touching point of your parabola. So parabola always cross it. It may touch x-axis, but it always cross y-axis if it's like goes upward or downward. There is sort of another parabolas that goes in this way, like it turned 90 degrees, but we're not going to talk about that. This sort of like, you know, this sort of A-level stuff, IB, and also like SAT, like level 2, level 1. So that's why we're not going to talk here. So that's why for y-intercept, what actually we need to do, I just simply prove y, if we have standard equation for the parabola, y equals x squared plus bx plus c, y we have c coefficient, which is very significant, and it becomes y-intercept. Okay, I'll tell you what you need to do. So technically, you know that when we have y-intercept, it means that for x coordinates of that point, it should be 0, right? So have a look, any point on y-axis, so any single point should have 0 coordinates, and exactly that point that lies on our graph. So here, the x coordinate for that is 0. So that's why we're eligible to put 0 into the equation. So that's why f from 0 equals y becomes our equation. So technically, coefficient and standard equation of a function c represents y-intercept. And indeed, if you put x0 in order to find y-intercept, you simply will have y from 0 equals to, so 0 everywhere except for c. So that's why technically c is y-intercept. All right, so now I hope you understand that, and that's why in our equation, why I decided like so fast that y-intercept is going to be 2 and no other value. I just simply have a look at the structure and see, okay, 2 is the free coefficient, so hence it becomes y-intercept. All right, so and one more, guys, one more thing that I want to share with you. If you have, let's say, vertex form, let's say x plus 1 squared, no matter, like minus 1. So what do you think about your y-intercept? Is it like this value? What do you think? Is that value -1? So if you say yes, actually you are not correct. You know why? Because this is not the standard form. And if you start coming back to from vertex, this is the vertex form, right? If you start coming from the vertex form into the standard, you will get x squared plus 2x plus 1 and minus 1. And what you'll get, you just get that 1 and minus 1 will be cancelled. And you finally stay with x squared plus 2x. So it looks like c in this case is 0. So keep in mind that this, from here, you need first to expand, or at least like pre-calculate, like if you square out 1 and subtract 1, you'll get 0. So you don't need to completely expand that, but so for sure you need to know that -1, the last coefficient here, is not the y-intercept, because after like expanding, you figure out that the real coefficient c for that parabola is 0. So be careful here. Given in vertex form, always try to pre-calculate c. And actually vertex form is pretty convenient because it gives you automatically vertex, right? Vertex coordinates, -1 and -1. And you also know y-intercept. However, in order to solve, so you need to, for example, have from vertex form, you need to get x-intercept, just simply x plus 1 squared minus 1 equate to 0, because that's when you have x-intercept. So y is 0, right? So for x-intercept, in here you can easily solve. You don't need to expand actually. Look, guys, you just simply need to solve this form. And then, you know, you're taking the square root out of both sides. In here, you will get x plus 1 equals, be careful, plus minus, you'll get two solutions of square root of 1, so which is 1. and x1 simply, when you take positive 1 will be cancelled, you'll get 0, and x2, when you take a minus, you'll get negative 2. You see, that's much more like convenient. If you have vertex form, it gives you like more options. You can easily find everything. Vertex is already given from h and k, so c you also can pre-calculate because it's just about numbers, arithmetic operations, and you can also find x-intercept with no problems. So hope you guys enjoyed that and hope you like that. This was like complete manual how to cope with quadratic functions, how to find x, y, about vertex, about like previous stuff. You just need to watch previous videos and try to practice, guys. So put likes if you like that and subscribe, don't forget it, so you support me. Daniel Dallas, peace.